Well, welcome back. Today's lesson is going to focus on more of a geometry topic. We are going to talk about similar polygons. So some of the things you need to know is what is a polygon and what does it mean to be similar? Well, a polygon is a sequence of consecutive line segments in a plane, and when you place them end to end, they form a closed figure. So basically, it's line segments that are connected together that don't intersect, they don't form X's, it just forms what's called a closed figure. There are no curves, they're all straight lines. So, to say that polygons are similar means they have the same shape, but they don't necessarily have the same size. Okay, so they're the same shape, but not the same size. So here's a figure where we have a polygon ABCD, and that's how we label polygons, is just by their vertices or their edges, their corners. And we're going to say polygon ABCD is similar to polygon WXYZ. And the order that we list the letters tells us which parts correspond to each other. And the symbol for similar is this little curvy thing. I don't even know the name of that, but it's like a little twiddle kind of a mark. And so here we have those two figures, ABCD and WXYZ, and we're saying that they are similar. So when we have similar figures, then their parts are also similar. And what happens is their angles are congruent. So the parts of similar figures that match are called corresponding parts. And the corresponding angles are equal in measure, and the corresponding sides are similar. So what does that mean? Well, when we have similar polygons, the angles are congruent, means they're the exact same measure, but the corresponding sides are proportional. So now you can see kind of where we're going with this. We've been talking about proportions, and one of the applications of the concept of proportionality is in similar triangles. So our symbol for similarity is that symbol right there. And our symbol for congruence is this symbol. It's an equal sign with the little similarity thing above it. So to be congruent means it's exactly the same in every way. It's the same measure. But to be similar means it's proportional. So let's go ahead and work with identifying some similar polygons. Our problem says determine whether rectangle HJKL is similar to rectangle MNPQ. So the first thing we want to do is check to see if we have corresponding angles that are congruent. And in fact we do. They're all 90 degrees. These are both rectangles. So all the angles are equal in measure. So that works. And our next thing is to see if the corresponding sides are proportional. So here's where the algebra comes in. To tell whether or not the corresponding sides are proportional, we would have to set up a proportion. So is side HJ proportional to MN? And JK proportional to NP. Notice these sides, HJ corresponds to MN, so if you look at the first two letters here, it's the first two letters in the other rectangle. Those are the corresponding parts, and that makes a difference. So that's what we're trying to prove. That's what our proportion will be. Now let's substitute in the things that we know. We know that HJ is 7 and JK is 3. We know that MN is 10 and NP is 6. So if we substitute those numbers in, we have a proportion. We just need to determine whether or not it's a true proportion. Well, if it's a true proportion, then we can take the cross products and they should be equal. 7 times 6 should equal 3 times 10. Well, clearly 7 times 6 is not equal to 3 times 10, so therefore these are not similar polygons. Here are two more examples. Go ahead and pause the video and see if you can come up with the proportions and determine whether or not those are similar figures. All right, I hope you took some time to do that. Letter A, okay? We have 8 over 6 equal to 12 over 8. Is 8 times 8 equal to 6 times 12? No, it is not. 64 is not equal to 72, so those are not similar polygons. How about letter B? Let's take a look at that one. We have 14 over 6. Is that the same as 3.5 over 1.5? Well, 14 times 1.5 is 21, and 6 times 3.5 is 21. So these two, for letter B, are similar polygons. So then we can come to what is known as a scale factor. And if we have the ratio of the lengths of corresponding sides of similar polygons is called the scale factor, and we can use that to figure out some missing sides or missing measures. So we're given that these two quadrilaterals are similar. They're telling us that. And we want to find the missing measures. Okay, so we're looking for side M over here. And we have side AD is 13, DC is 10, CB is 12. So we want to know what is the length of side M. So if we can find the scale factor, then we should be able to solve that. Well, we have two sides that are corresponding here. DC and ZY correspond, and that can give us our scale factor of 15 over 10, which is the same as 3 over 2, which is the same as 1.5 in decimal. So we can use that scale factor then to go ahead and find our missing side. So the sides that are in quadrilateral WXYZ are 1.5 times bigger than the ones in ABCD. So what we're going to do is we're going to say M is equal to 3 over 2 times 12. This side right here, side M, will equal this side times the scale factor. So that works out to be 18. So the length of side M is 18. Ratios of similar figures. If we have two figures that are similar and we know their scale factor, then the perimeter of the figures have the same scale factor. The ratio of their perimeters is the same as the ratio of their sides. So let's take a look at where we would apply that. Here we have triangle LMN being similar to triangle PQR. Okay, remember the order of the letters matters. If the perimeter of LMN is 64 units, what is the perimeter of PQR? Well, since they are similar, first we need to find their scale factor. So LM corresponds to PQ. So we can say that 24 over 18 is their scale factor, which is the same as 4 over 3 in simplified form. So therefore we know that the perimeters, the ratio of their perimeters is in that same scale factor. So the perimeter of LMN, they told us, is 64, and the perimeter of PQR we're looking for. The scale factor is 4 to 3. So now we can do our cross products. 4 times x is equal to 64 times 3. 64 times 3 is 192. Dividing both sides by 4, we end up with x is equal to 48. So the perimeter of triangle PQR would be 48 units. Little side note over here, in naming similar triangles, the order of the vertices indicates the corresponding parts. Read the similarity statement carefully to be sure you compare corresponding parts. You can't be too careful there. Here's one for you to try on your own. It says square KLMN is similar to square TUVW. And they give you the perimeter of the first square, and they want you to find the perimeter of the second square. Go ahead and pause the video and work on that, and we'll go through it when you get back. All right, hope you gave that a try. So if we have the perimeter of our first square is 32 units, what is the perimeter of the second square? Well, it's the same as the ratio of the sides. So we could say 8 is to 16 as 32 is to x, where x is the perimeter of the bigger square. So 8x is equal to 16 times 32. And 16 times 32 is equal to 512. And if we divide both sides by x, see if I can, divide both sides by 8, I think I said x. Dividing both sides by 8, we end up with x is equal to 64. So that says that the perimeter of the bigger square is 64 units. All right, here are some problems for you to try. I think we have a total of 4 problems here. On number 4, make sure that you're showing your work and not just circling an answer. So show me how you come up with your answer for number 4. So I need to see either a proportion or your scale factor and how you're coming up with that. And bring those answers to class. We'll see you next time.